All right, so this is passage 5 of our ACT form B04. For this passage, it says, for a demonstration on an electric current, a teacher mounted two identical copper cables vertically and connected the cables to switch boxes as shown in figure 1. And so here's your figure 1. Each switch had 3 positions, X, Y, and off. The teacher flipped both switches from the off position to position X, and the cables bent toward each other. Then she flipped one switch to position Y, and the cables bent away from each other. Finally, she flipped the other switch to position Y, and the cables bent toward each other. See figure 2. So when they were the same, both X or both Y, they bent toward each other. When they were different, X and Y, they bent away from each other. The teacher asked each of the 3 students to explain these observations. So student 1 says the switches controlled the direction of current flow through the cables, upward in position X, downward in position Y. Each current generated an electric field. Because each current consisted of positive charges, its field pointed in the direction of current flow. Electric fields attract each other when parallel and repel each other when anti-parallel, or pointing in opposite directions. The field generated by one current attracted or repelled the field generated by the other current. Student 2 says the switches controlled the direction of current flow as student 1 described. However, the currents consisted of negative charges. Each current generated a magnetic field. A magnetic field exerts a force on any change in charge in motion, and this force is always perpendicular to the direction of the charge's motion. When the currents were parallel, the field generated by one current attracted the charges in the other current. When the currents were anti-parallel, the fields generated by one current repelled the charges in the other current. Then student 3 says, the switches control the signs of charges in the currents, positive in position X, negative in position Y. Regardless of whether they are at rest or in motion, charges of like sign attract each other and charges of opposite sign repel each other. The charges in one current attracted or repelled the charges in the other current. Okay? So what you see with these types of passages, when you have different student ideas or different various like scientific or different viewpoints, a lot of times what you'll see is part of the explanation is true or consistent with what you may know to be true in the situation, and then part of it's not. And that's one of the things I think can make these passages difficult. Because sometimes if we know about this information especially, we can get really hung up on whether what they're talking about is right or wrong and wanting to answer things that are right based on what you know to be true about how charged particles or charges interact rather than working from the information that's given. So these passages, I'll say, are easier for you when you have no idea or none of the background that kind of goes along with this sometimes, because then you can really focus on the student ideas. That said, a lot of times there are a couple of questions that you require to have some prior knowledge to really be able to answer these. That's the case for the first question here. So let's look at that one. Question 28. Each of the following statements was either claimed or implied by student 3, which is scientifically inaccurate. The only way we can answer when something is scientifically inaccurate is to have prior knowledge about the situation, right? So if you don't know much about charges or how charges interact or anything like that, you're going to have kind of a hard time with this question. So let's first see what's implied or claimed by student 3. Charges of like sign attract each other. Well, does he say that? They say, yep, charges of like sign attract each other. So he did say that. G, charges can be at rest. He does imply that when he says, regardless of whether they are at rest or in motion. H, a current consists of charges in motion. Charges in one current attract or repel the charges in the other current, so that's implied again. There are two possible signs for electric charge, positive and negative, and he mentions that up here. So all of those are consistent with something that student 3 said, so then we have to rely on what we know about prior knowledge, what's actually true here. The only thing that's really actually scientifically true, well, I should say, we want to know what's inaccurate, excuse me. Charges can be at rest, that's true. A current consists of charges in motion, that's true. There are two possible signs of electric charge, positive and negative, that's also true. F is the only one that's not true. And again, for what we've been talking about in this specific class that I'm talking to, we've talked about the fact that opposite charges attract, like charges repel, right? So we know that F should be inaccurate. We should have the prior knowledge to answer that one correctly. 29. Assume that the currents in the demonstration consisted of a single type of charged particle. If student 2's explanation is correct, these particles were most likely what? So student 2 says the currents consisted of negative charges. We know that protons have a positive charge, electrons have a negative charge, neutrons have no charge, photons are pieces of light, packets of light. So electrons, B, are the only particle in the list that have negative charge. Again, you have to have that prior knowledge. I think that's really pretty common prior knowledge to have. I honestly think number 28, that prior knowledge is also relatively common to have. 30. If student 2's explanation is correct, then a magnetic field would be expected to exert a force on which of the following objects? So student 2 says a magnetic field exerts a force on any charge in motion. This is the key piece of student 2's argument that we need to answer this question. So we have to go back, kind of reread that. And so then it comes down to knowing whether you have an ion or a neutral atom. We again should have the prior knowledge that a neutral atom has no overall charge. An ion, however, is charged. So then F, an ion in motion, ion meaning it has a charge. And then the other part of it is motion or rest. And here it says it has to be in motion. So we need something that has a charge in motion. That fits with F. Okay? So there's a little bit of a prior knowledge piece here as well. Being able to differentiate between ion and neutral atom and knowing which is charged and which is not. 31. Based on student 1's explanation, when the switch on the left was in position X and the switch on the right was in position Y, were the electric fields generated by the current parallel or anti-parallel? So again, we go back. We see that they repel each other when anti-parallel is what they say. And we look down here, combine that with this. X and Y repel each other. So we're going to say anti-parallel because they're repelled, so C or D. Then we also need to get the reasoning correct, right? So because the left-hand current was flowing upward, the right-hand current was flowing downward. Well, we've got to look and we've got to say, okay, upward in position X, downward in position Y. And is that what we've got? Left in position X, right in position Y. Yep. So that means we've got up on the left, down on the right. C then is consistent with that. Okay? So there are lots of different things we have to combine here. We have to combine this information, this piece of information, this piece of information all together to be able to answer this correctly. So look at 32. Which of the following figures is consistent with both figure 2 and student 3's explanation? Okay? So figure 2 says when you have X and Y, they repel. When you have the same, they attract, right? So X and X, that would be good. X and Y, that'd be good. Y and Y. This one automatically we can take out because when they're the same, the figure 2 is showing that they're attracting, right? So now we've already taken it down to 3, just from the figure 2 portion. Now we need to go along with student 3's explanation. Student 3 says the switches control the signs of charges and the currents positive in the X, negative in position Y. And then they said regardless of what they're at rest or motion, like sign attract and opposite signs repel. And so again, we know that that part's not true, right? We know that like charges don't attract and opposites don't repel. We know that's not true, but we can't get hung up on that because that'll give us the wrong answer because we're working based on student 3's explanation, not what we know to be true scientifically. So based on student 3's explanation, F then would show like charges that are attracting one another, right? Here this is like charges repelling, here's opposite charges attracting. So F is the choice that is consistent with figure 2 and student 3's explanation. If we are talking about what we know scientifically, you may have chosen H because you saw opposite charges attracting, right? But that is not consistent with what student 3 said. That's why H is not the correct choice here. Okay? And that's part of what makes this one tricky or difficult because I want to select H because I'm like, well, that's what happens. That's true science right there. But that's not what they're asking.
So if F on the same charges attracts, why wouldn't it go J? Why wouldn't they repel since they're opposite?
Right. So okay. So the question was, if like charges attract, why isn't J a good option? Because opposite charges repel. And remember, J is not a good option because J is showing Y with Y, right? And so J is not consistent with what we see down here. When we see them repel each other, it's X with Y. So 33. In regard to attractive and repulsive interactions, how does student 1's explanation differ from student 2's explanation? Student 1 claimed what? So student 1 claimed that electric fields attract each other when parallel, repel when anti-parallel. So let's look for that. A field attracts or repels another field. That would be consistent, right? Because they're talking about electric fields. So a field attracts or repels, that's all right. A field attracts or repels, that's all right. Charges, no, these aren't going to work because student 1 didn't talk about charges in that way, right? So we're down to A and B. Student 2, what did student 2 claim? They claim that a magnetic field exerts a force on a charge in motion. So where student 2 claimed a field attracts or repels charges, that would be true. A field attracts or repels another field, nope. So then A has the correct combination of what student 1 said for the first part and what student 2 is talking about in the second part. Does that make sense? Again, we're having to kind of combine a bunch of different information here. Last, we've got 34. So on 34, which of the following procedures would best test student 2's explanation with current flowing through one cable, determine what? So student 2 again talks about the fact that when current is flowing, it generates a magnetic field, right? So that's the key thing we're going to be testing here. So if we go through this, a positively charged plastic rod, when held at rest near the cable, attracts or repels the cable. No, student 2 would say there's nothing there because you're not looking at motion, charges in motion. You're just looking at charges static on a plastic field or plastic rod. G, a compass needle is deflected when brought near the cable. That's a good option because we know compasses interact with magnetic fields, right? And that would be a way to test a magnetic field. H, an uncharged rubber strip when held at near the cable bends toward or away from the cable. No, that would really probably go with magnetic fields. A light bulb was illuminated when connected to the cable. Again, that doesn't have anything to do with magnetic fields or what student 2 said. So I really think G is going to be the best way to test student 2's explanation.